When we talk about precision in the lab, we're talking about the repeatability of a measurement. Precision gives a measure of the reliability of a measurement. So if you were to take the same measurement over and over again, would you get the same answer over and over again? Not necessarily so, because there's always random errors associated with your measurements. So you may not always get the exact same answer. How much variation there is describes the precision, is a description of the precision. There are two ways that we can describe the precision or characterize the precision of a measurement. The first way is using the sig figs associated with the measurement instrument. So if we look at a burette, this is a tube of glass that has demarcations for different volumes on it. And maybe there's a liquid, there's water in here, and it creates a meniscus inside that tube. When we read the volume associated with this amount of water, we're going to look at the minimum of the meniscus, the bottom. So I'm going to go across and I'm going to read that as definitely we know it's between 6 and 7. So this first digit is significant. We definitely know that it's between 6.5, 6.6 and 6.7. So the tenths place is a significant digit. But the hundredths place, the 4 that's here, is an estimate. So we'll always read our glassware or our instruments to the first uncertain digit. In this case, that's the thousandth place. That means that when we read this piece of glassware, we have 3 significant digits or 2 decimal places. If we had a different burette that didn't have as many demarcations for the volumes, then we can't read to as many decimal places. So here we know we're between 6 and 7. There is a line at 6.5, but there aren't lines for all of the other tenths places. So we can't decide what is, we're not sure, we're not certain what the hundredth place would be. We're really not even certain what the tenths place would be. So maybe this is 6.2, maybe it's 6.3. We don't know what that tenths place is for certain. You may think that by eye it looks like 6.25, but we can't be certain. So 6.2 is what I would read here. We might argue about whether that's 6.2 or 6.3, but that decreases the repeatability of a measurement using that piece of glassware. So this second piece of glassware has less precision than the first piece of glassware. When we look at another example, the Bureau of Standard Time here has 8 significant figures. Jerry's analog watch has 3, and Jennifer's digital watch has 5. So the most precise watch here is the Bureau of Standard Time, and the least precise is Jerry's analog watch.